Good morning, students. In continuation of my lecture on database management system, today I am giving lecture on index structure, that is a part of, you can say, database management system, a very important topic, that how do we index the records and how to fetch the records much faster as compared to without the concept of indexing is used. So before moving to the indexing, how it is done, what is the procedure, how many types of their indexing are being there. So before moving to that concept, let me tell you that before moving that, what is the concept we are going to talk about. We are talking, so let's understand a brief introduction as an introduction about it. That in a concept of indexing, you should understand that basically we are talking about of fetching the records, right? So when we are talking about of fetching the records, that means ki fetching of the record should be little in a way that it should be faster also and cost effectiveness also. Okay, so as a logical term, if we understand in a term of logical way, that indexing is basically done on the data that is you can say saved or stored into the disk. Disk means that now we are talking about the secondary device, secondary memory. Okay, so does that mean कि if I am asking a particular type of a fetching a record, if I want to say that I need to fetch a record from a student table where n number of records are being stored of a student table, so how do we do that? How do we do that? Do we exactly say to the CPU of a system, get give me this record? Does the CPU do it actually? So we should understand the concept that all the data which whatever data I have in my device, in my, you can say, system, that is stored into a secondary memory. Okay, so secondary memory means ki we are fetching the records from the disk which is at the location which is in the secondary memory, and from there I am getting that particular information into the main memory, and then from the main memory I am been getting this as the output of what I asked. ठीक है ना? So over here we will understand with a very small diagram of, you can say, hard disk, that what exactly and how this data is stored in a format in the form of, you can say, records. Okay, so this is the you can say figure of, you can say, this is the diagram of the hard disk, where I am saying that it is divided into the number of blocks. Okay, hard disk is divided into the number of blocks and data is stored in the form of records in it. ठीक है ना? Over here you can very easily see that I have divided the hard disk into block 0, 1, 2, 3 like on, and now n number of blocks are there into my hard disk, and every block is having some records. Okay, every so when the data is fetched from the secondary memory, ठीक है ना, from the it is asked, you can say, from the CPU, then it is fetched from the secondary memory to the main memory. Now if I say there are, you can say, n number of records lying in my hard disk, so if I assume that there are, let us say, 10,000 records. Okay, if I am saying, let's say there are 10,000 records, into my hard disk, and every block can have 100 records into it. Okay, if I am saying that I have 10,000 records, sorry, 10,000 records are there in my table, let's say a student table is there, and one block can store, let's say, one block can store 100 records. One block can store 100 records. So in all, how many blocks in that case I will be needing? So it's very simple to calculate. Number of blocks required in my hard disk will be total number of records divided by number of records that a particular block can hold, isn't it? Isn't it? Number of blocks will be how much? Number of blocks will be total number of records that I am having divided by the number of records that a particular block can hold. So we'll be having 100 blocks. Clear? So I'll be having 100 blocks in this case. Like this, it is calculated that how many blocks can be there into my, or how many blocks are needed as per my data that is has to be stored. Now if some data is asked, okay, if some data is asked from a or some query is being executed, let's say if select a particular type of a record from the table of the student where the, you can say, roll number is 10, 20, 500, something like that. So which is stored, you can say, always into the secondary memory. That is not stored into the main memory, it is stored into the secondary memory. Okay, so in that case, what will happen, the data can be stored in, you can say, two ways. As we know that the data can be stored in two ways. It can be sorted or unsorted. It can be sorted or unsorted form. ठीक है ना? Sorted means, you can say, ordered or unordered. Sorted, unsorted, ordered or unordered form. So if I am saying that it is an unordered form of data is stored into my data, into my hard disk, then what will be there? In what format? So in that case, what will happen? That my data is stored into the form of unsorted. If I say the data is unsorted, then in that case data will be in the form of, let's say, 1, 2, 3, 10, 50, 20, 100. Clear? So this is in the form of unordered form, that is unsorted form. So how it will work? One block will be called into the main memory now in that case. Okay, now whatever blocks I have told you that it is divided into the memory, is divided into the hard disk, is divided into the number of blocks, and we have 100 blocks as of now because we know that we have 10,000 records. So in that case, what will happen? The blocks will be called into the main memory. So one block will be called and will be checked whether my data is existing or not. If it is existing, the record is being fetched from that block, and that block is sent back to the secondary memory. If not, then it is already sent back, then another block is called into action. Likewise, the blocks exchange takes place between the main memory and to the you can say secondary memory. So it is searched in that way, and the okay, and that this is the actual procedure that happens between the memory and to the you can say main memory and to the secondary memory till the desired is result, that whatever is desired is obtained. So for this we can say basically the indexing is used. Okay, indexing, you can say, it only works on blocks. ठीक है, called as I. Now blocks के ऊपर जो काम करती है indexing, I am saying that indexing works only on blocks. ठीक है, that means I am saying that blocks work based on IO cost. Block works based on IO cost. What does this mean? The cost, you can say, the cost of which will depend on that how many blocks are being called. The cost will depend on how many blocks are being called. So we should have a, you can say, method over here which we should call, say that the minimum number of blocks are required or minimum number of blocks are to be fetched. We should have a concept of that form. So you can say into the similar way, if we say an example of a book, let's say it have, you can say, 1000 pages, and a particular topic is to be searched into that book. Then if we do not have an index, If we do not have an index, then in the worst case what will happen, that my particular topic is lying you can say in the last page, and the indexing is not there. And if it is lying into the, you can say, extreme case, in the worst case, so I have to, what I have to do in that case, I have to fetch all the number of pages into the book. And in the best case can be that as soon as I turn one page, my topic is found. And so best case can be that, and so we should understand the concept by considering the worst case, which says that I have to search the entire book if the indexing is not being done. So, and an average, if we say that I have to search 500 pages, so in that case what will happen, index, you can say, what will happen in that case, that we can use in that case by sort of thing, searching can be done in that case with based on binary search also. We can apply the binary search in that case. Okay, so index is used, then it will be saying that it will be in a very few pages, so it will be saving a lot of time, and the searching will be faster, because as we know in a book that the number of pages in the index are very few, let's say 3 to 6 to 7 pages only. And since the topic is to be searched into the index, then we finally get the name of the topic corresponding to the topic. We will search the page, and then in that page we will go inside the book and can search our topic. Okay, therefore the indexing involved is checking less number of blocks. If the indexing is there, we will be having less number of blocks to be called into you can say main memory for fetching the output. So this is known as the IO cost, which is reduced in this way if the indexing is used. So if we, as we are talking about the sorted type of a file, and where we can say that if sorted file is there, we can use the binary search algorithm. Okay, as we say that for searching a record we have to do, you can say, two things. We should make it clear that for searching a particular record हमको दो तरीके की चीज़ों का बहुत ध्यान रखना है. First is that we need a block, okay, and second that record into the block. That means what, the number of records in the block, you can say, are not, you can say, not much, you can say. In every block will be having, as I have taken an example of 1000 records, and 1000 records are divided into 100 blocks, then every block is having only 10 records. So if I am able to reach to the particular or I am reaching to a block where my record is lying, then it will be very easy for me to fetch the record from that particular block. The tedious task is what over here, the tedious task over here is to find the block. The time consuming is for searching the block, not the record. So over here we will always assume in the indexing, complete indexing, which we will be discussing, that the time of searching the record inside the block will be negligible, and we will be ignoring that time. In the numericals also we will be ignoring the time that will be required to fetch the record inside the block. We will consider only the time that is required to fetch the block where my record is lying. Okay. So we can also understand in a way that if 10,000 records, as I told you, are there, and 10 records each block can hold, so in that way we have 1000 blocks, isn't it? So if we want to find, let's say, a record of 9524 number, if we want to find this record, okay, so we will say that we can apply the binary search in that way, because my records are already sorted. I'm saying if I'm talking about the sorted way, then I can apply binary search, which is order of n, isn't it? That means if I have to find, I will say log 2 n, that is equal to log 2, 1000 records are there, so it will be nearly equal to 10. So I have to search only 10 blocks. So in you can say worst case, we have to search only 10 blocks in that case. And in case of unsorted, if I say, what will happen? In worst case, it can be in the last block, as I told you. So we have to read, you can say, the entire 1000 blocks. If we'll have a small file, that means if indexing is required, if we have a small file, then we can say that it is easier to fetch the record from that particular file, which is called as index file. Okay. So over here we will understand that index file contains you can say 2 columns. Index file contains 2 columns. Let me get back to the initial after understanding this basic concept. After understanding the basic concept that why the indexing is required, let's move to a, you can say, a small definition of an indexing. Okay, over here you can see indexing is a data structure technique which allows you to quickly retrieve records from a database file. An index is a small table having only two columns. I already told you that it has two columns. The first column comprises of it's a key, you can say. It's a key, first column, and second column contains the set of pointers. I will tell you with the help of an example also that what does basically mean. Second column will be only a pointer for holding the address of the disk block. Please make it a little understanding should be clear over here, that the second column will contain set of pointers for holding the address of the block. Okay, where that specific key value is stored. Okay, I hope it is clear till here. So as moving to the structure of the index in the, you can say, index file, let me explain you again. This is my index file which contains two columns. This is my index file which contains two columns. Okay, this is my index file. Clear? So what it has said just now, we have gone through the, you can say, definition, which says that it contains of two columns, in which first column is the key element. That is, this column will be termed as search key. This will be a search key. It will be a search key, first column. Search key basically means what? It will be a primary key or a candidate key on behalf of which we are going to search my record. As I said, that if we are considering an example of a student table, so in that table, if the record is found is to be searched for the student, that means I want to have a record of a particular student which having so and so roll number. So this search key will be treated as a roll number. Will be as a roll number. Okay. So in that case, how to, you can say, search a particular record. So this is my, you can say, as I told you, this is a hard disk which is divided in blocks, and each block is having records, having 10 records, let's say. Clear? So this my second column, which just now we have seen with the help of a definition, that the second column is the, you can say, what? It is the address of the block in the secondary. So over here I am saying that this is the block which is having the records into it. These are the records. Okay, and let's say if every block is having 10, that means it is starting from 1. Okay, and then it will be starting to 11, then it will be starting 1, 21, 31, 41, likewise it will be having in this form. Clear? In this form the records will be filtered. Since it is a sorted file, so it is easier for me to fetch the record. So in that case, block pointer, this is my second, which is termed as BP, that is a block pointer. See, to fetch the now record, I want to fetch a record of a student having the roll number, let's say 25. So since the file is sorted, I know it that 25 roll number. Over here, if I say the 25 roll number, over here the records will be fetched as I case. First will be a search key and second will be the block pointer. Okay, clear? So in that case, what will happen? If I say that I want to have a file with a roll number of 25, so in that case the block pointer will be searched between, it will be reaching to the, not to the roll number directly 25, it will be taking, the block pointer will be taking me to the head of the block where the 25 record is going to be there. Clear? So it will be going to have point of my you can say pointer will be pointing it towards the block B2. Clear? So this way it will be easier for me to search, and in that way the size of the, you can say, uh, of the index file matters a lot to search the particular record. Now how to second point we should understand that how to make the file size, index file size small. How to do that? In order to do that, in order to do that let me tell you that if I am having, you can say, an index file, if I, with the same example, you can say if this file, which is a, you can say, secondary device, secondary disk, you can say, and each record where the record, students record are stored, let's say student record number 1 is there, which is having its roll number, its name, its, you can say, subject details, its guardian details, its city address, everything is there. Okay, so the same thing, whatever, why I am saying so is ki the complete detail of the student is there into the main file, but this complete detail is not present into the index file. We are keeping a very small detail, so the size of the file will be definitely reduced. Okay, so if I say over here that the size of the record over here is 100 bytes, 100 bytes, record size let's say is of 100 bytes, then the index file size can be of, let's say, 10 to 15 bytes. It will be only, let's say, 15 bytes. In that case it will be only of 15 bytes. Okay na? Then if it is 15 bytes, like how you are saying so that it is only 15 bytes, because I have already told you that all the complete information of the student is there into the main file. It is there only into the hard disk, but that complete information is not into the index file. Only two columns are there because it contains only two columns, having first the search key and another is the block pointer. So in that way the size is reduced, and in this case only, you can say, over here 10,000 records were there. So size is reduced means what? It is containing only the block pointer, block address. So over here it will be only what? How many? 1,000 records. Only 1,000 records will be there. So we have reached from 10,000 to only 1,000. And this was in the case of sorted. So in the case of unsorted, if I say, so in that case what will happen? Base address of every block in index file will not serve any purpose to us. हम इंडेक्स फाइल में ब्लॉक पॉइंटर के बेस पे हम लोग कैलकुलेट ही नहीं कर सकते. वी कांट कैलकुलेट इट बिकॉज इट इज एन अनसॉर्टेड वे. When the data is unsorted, records are stored in an unsorted way, we cannot find on the base of block pointer. Okay, so this type of, you can say, now the type of 2 indexing I'm introducing, that is the sparse and the dense. So in that case, if this in the case of unsorted, if I'm not able to get with the help of block pointer, so complete information of the records will be there into my index file. Okay, so this is known as dense, you can say, indexing. Whereas what we did earlier, where we have said that the files are sorted and I am storing only the block pointers, so that is type of indexing, you can say, it is known as a sparse index. Clear? I hope you would have understood what is the basic introduction, what is the basic need of indexing, why do we need to have an index, and why the indexing is required into the database management system to fetch the records, how it is faster, why it is cheaper. Clear? So in my further videos we'll be discussing what are the, you can say, advantages, disadvantages of indexing, then the type of indexing, and all the types we'll be discussing in detail. Clear? I hope you would have liked my video, and if there is still any you can say point that has coming into your mind, you can put it into my comment box. Thank you for watching my video. Thank you.